Hi everyone and welcome to our Python basics video. Today we will be diving into operators and expressions, covering everything from arithmetic operators to operators, precedence and associativity. Arithmetic operators includes addition, subtraction, multiplication, division, modulus and exponential and floor division. Okay, first let us start with our addition. Let us take two values, a is equal to 10 and b is equal to 5. So the first arithmetic operator is addition. So it is like we use symbol plus, print a plus b. The next would be minus, print, this is subtraction, a minus b. The difference is 5. Next operation will be multiplication. A multiplied by 2. And next operator would be division operator. Let me write this hash division operator. Again print a divided by b. The response will be 2. Here we are getting 2.0 as a floating point value. The next operator would be modulus operator. Modulus will not be a% b. Will get 0. And the next operator would be exponential operator. We can denote with double star. This is asterisk. Print a exponential b and output will be 10 to the power of 5. And next operator would be floor division. We can denote this with double slash. Print a floor division by b. You can see the response is 2. Next we can see comparison operators. Comparison operators includes equal to, not equal to, greater than, less than, greater than or equal to, or and less than or equal to. So these operators, we can see examples for this. Print a is equal to b, a is equal to 10 and b is equal to 5. Since they are not equal, we are getting a boolean response as false. Next we can see print a is not equal to b. Since 10 is not equal to 5, you are getting true response. Print a is greater than b. Since 10 is greater than 5, we are getting true. Print a is greater than or equal to b. Since a is always greater than equal to b, hence we are getting true. Print a is less than b. Since 10 is not less than b, we are getting false. Print a is less than or equal to b. Since a is 10 is neither less than or equal to 5, that's the reason we are getting false. Okay, now let us start with logical operators. Basically, we have three different types of logical operators. They are logical AND, logical OR, logical NOT operator. These logical operators are used to form complex conditions by combining multiple comparisons. Let us see some examples here. The first example is for logical AND operator. We know a is equal to 10 and b is equal to 5. I am trying to print the condition a is greater than 5 and b is less than 10. Since both a is greater than 5 is true as well as b is less than 10 is also true, hence we will get the logical response as true. The next operator would be OR operator. Logical OR operator. Print a is greater than 5 and OR b is greater than 10. Since a is greater than always 5 as well as b is greater than 10, so we will get true. The final operator is logical NOT operator. Print NOT. NOT always gives a negation of any status. For example, I am passing a true boolean value, a is greater than 5 and b is less than 10, which is already a true in the previous logical AND operator example. Since that is true, when you are adding a NOT, that makes false now. Yeah, this is the list of assignment operators. These assignment operators include standard equal sign as well as combinations with arithmetic and bitwise operators. These are basically useful for updating the values of variables. Here are some examples we can see. Assignment operators. I am defining a variable 5, variable x, and assigning value 5 and printing the variable x. So I will get 5. Add and assign operator. I am using add and assign operator. Plus 3 and print x. You can see the increment on top of the initial value. Next is x minus equal to 2 and print x. You can see the response was 6, which is less than 2 of actual value 8. Next, I am multiplying and assigning value to x. So I am multiplying it with 4. Print x gives 4 times of 6. Right, 24 we are getting. Now I can divide and assign the value with 3. Since it is 24, I can print the value x, which is 24 by 3. So you are getting 8. Print. Let me add floor division. Modulus assign equal to 5 and print x. will get 3. And we can do floor, division and assign with 2. I am printing X. 1 as the response. X multiplied. It is an exponential, not multiplication, sorry. I am exponential, I am doing with 3. Print X. A variable A is equal to 3 and B is equal to 5. Now we can write A bitwise assignment operator, bitwise and assignment operator equal to B, and print A. Basically previously A is 3, now after assigning with bitwise and operator we could see a difference in the response. Now it is showing us 1. Okay, let us see how it works for bitwise OR operator. A is equal to 3, B is equal to 5, and assign A with bitwise operator equal to B. Now you can see, you can print the value A, which is different from the previous value. You can see here it is coming as 7. Okay, so now let us check bitwise XOR operator. Again define A is equal to 3 and B is equal to 5, and write A bitwise XOR operator or XOR operator is equal to, and assign it with B. Okay, and print A. A is equal to 3 and B is equal to 5, and I can use right shift operator, A right shift operator with assignment, right shift assignment operator and with B. Now I can print A. You can see a different value now, not 3, so it is going to be 0 value. Now let us check the response for left shift assignment operator. Let us take again the similar values. A is equal to, same values, A equal to 3 and B is equal to 5, and A left shift assignment operator with B, print A. You will see a different value now altogether, that is 96. Bitwise operators are used to perform bit level operations. Let us start with some examples here. Let us suppose A is equal to 10 and B is equal to 5. Print A bitwise and B. So here I am using bitwise and operator between two variables. Gives 0. Since I have A is equal to 10 and B is equal to 5, I can convert this value A is equal to 10, but this is in decimal, it is in binary, would be 10 10, and B is equal to 5, right? This is going to be 101. So this is the four places I can have. If it is A and B, right, it should have 0 and 1 is always 0, 1 and 0 is always 0, 0 and 1 is always 0, and 1 and 0 is always 0. This is going to be a 0, right? So that's the reason we could see the response came from the binary operator as 0 when you print this in Google Colab. Okay, now let us see, let us print A or B. You can see now 15 has come out. Okay, why? because if I do 1 0 1 0 0 1 0 1, if I do a binary OR operator, 0 and 0 or 1 is 1, 1 or 0 is 1, 0 or 1 is 1, 1 or 0 is 1. So this is going to be a 15 equivalent in decimals. Right. Now let us see how it works for XOR operator. Print A XOR B. This also giving 15. Why it is giving 15 is also is based on truth table. So basically what happens is A XOR B is equal to A B star plus A star B. Okay, so you can use this truth table. I request you to go ahead and check the truth table. We have NOT operator. NOT operator is always now we will see NOT operator. Yeah. When you run this, you will see a 11 minus 11. Okay, this is the output of the negation. Now I am using print A left shift 1. Let us suppose I have a value A is equal to 1 0 1 0, right? I am doing left shift 1. So I wanted to shift one value in left side, right? So let us see what is that I have. This is an example. This is a list of I'm using till 20. I'm generating 20 decimal equivalent. Sorry, I'm trying to generate binary equivalents of each and every things till 20 in decimals. Okay, let me put 8 places. Right. So now what happens is, what I am trying to do is I am trying to do a left shift. So what I have to do is I have to have this value and add additional 0 here. This gives 1 0 1 0 and 0 at the right side because it is shifting towards left. When you do the left shift, we will be having one vacant place. This vacant place will be filled by a 0. That's the reason we got a equivalent for this binary value is 20. So that's the reason we are able to see response from the print statement is equal to 20, right? Okay, next let us see print A right shift 1. Print. It is coming 5. Why it is 5? Let us see. A is equal to 1 0 1 0 and I wanted right shift 1, right? One digit is should be shifted, right? So I am going to remove this. So when you remove this one, what happens is, and I am removing this 1 0 1 and you will have a 0 here. Okay, this is equal to 5 in decimal. Hence that's the reason we are getting 5 in Google Colab. Bitwise operators include Bitwise AND, Bitwise OR, Bitwise XOR and Bitwise NOT, left shift and right shift operators, and these operators works on the binary representation of the numbers. Now let us discuss expressions and statements. Expressions are combinations of values and operators that finally gives a value, but statements are instructions that perform an action Okay, let us see some examples now. I am writing some Python code. For example, I have a result is equal to a plus b. Now let me define a as well as b. A is equal to 10, b is equal to 5, and I am writing and multiplying with 2. Right? This is an expression basically. This is an expression. Now let me print. So this is basically a state expression that gives a value as a result. Okay. And here we are using an assignment operator. Let me run this. If x is greater than equal to greater than 5, then print x is greater than 5. This is a statement. I can say this is a conditional statement. I can have one more example for the looping statement. This is loop statement for I in range of 3. I am going to print the value of I. Let me run this. I'm sorry, this is for I in range, so it will work. This is a statement that I am passing to the system to provide the value of I in range between 0 to 3. Now let us see operator precedence and associativity. Operator precedence determines the order in which operations are performed, whereas the associativity determines the order of operations when operators have the same precedence. Okay, now let us see some examples. I have a result is equal to 10 plus 2 multiplied by 3. Right, here we'll take okay. This is addition, this is multiplication. So multiplication will be given higher priority than the addition. Now print result. We got 16. Let us suppose I am using a different statement with same values. Okay, I am using 10 plus 2. Now I am multiplying this value with 3. The response that you see now is different from the previous one. Here we got 36 because here the value 3 is multiplying the entire parenthesis 10 plus 2. Here parenthesis has been given higher precedence than the multiplication. So this is operator precedence, but let us see operator associativity. For example, I have a result equal to 10 minus 3 minus 2. See, here we have 10 minus 3 and minus 2, and let us see what happens when I print it. I am getting output as a 5. Here subtraction is the left associative. So there are 2 times I am subtracting from 10. So 3 and then 2. First I am subtracting 3 from 10 and then 2 is done. So this is a left associativity. For example, I am trying to do a different operation. For example, I am trying to do and the division example result. Ten divided by 2 divided by 3. So I can take 2 divided by 2 and print. Let me run this. I'm writing print. Right, result. Here the division is left associative again. Okay. So the operator precedence determines is the order in which operators are evaluated. Multiplication and division have higher precedence than addition and subtraction. So operator precedence determines the order in which operators are evaluated. Okay. Thus, operator precedence determines the order in which operators are evaluated. Basically, multiplication and division will have higher precedence than the addition and subtraction. Okay. Associativity determines the order in which operators of the same precedence are evaluated, typically from left to right. So till now, we have covered operators, expressions and statements, including arithmetic operators, comparison operators, logical operators, assignment operators, bitwise operators, expression evaluations and statement types. Along with it, we have covered operator precedence and associativity. I hope you found this introduction very useful and are excited to continue your Python journey. Thanks for watching and happy coding.